This is a Ford ECU repair video, and you often see me use the gas analyzer and the dyno to confirm my repairs. But I want to take a second and explain these gases and also try and clearly explain something that you hear almost daily now that I've never heard a clear explanation of. So stick with me, I don't care who you are, you're going to learn something from this. So the classic automotive pollutants have always been traditionally hydrocarbons, which is unburned gas, and carbon monoxide, which everybody should know what carbon monoxide is. It's the silent killer. It comes from incomplete combustion. And newer on the list is NOx, or oxides of nitrogen. They're no good when they mix with sunlight. But the two classic ones are hydrocarbons, and on an automobile, this is basically raw unburned gasoline. So a misfire, an ignition problem, a mechanical problem is going to cause this to go up. Carbon monoxide is caused by incomplete combustion. More hydrocarbons than there is available oxygen to convert all of the hydrocarbons into carbon dioxide. So you need enough oxygen to burn all the gasoline and have just carbon dioxide left. So in a vehicle, carbon monoxide is usually caused by a rich mixture. And this on a modern catalytic converter vehicle should be around 0. On a carbureted vehicle with no catalytic converter, 1 to 2%. Hydrocarbons should be below 100, no catalytic converter. Modern car, they should be under 10. The one I really want to talk about is carbon dioxide, because traditionally this has not been considered a pollutant or a threat. This has been considered the perfect goal, because perfect combustion of gasoline or hydrocarbons will result in just carbon dioxide and water left over. But today we're starting to hear all about carbon dioxide. And that's what I want to take a second and talk about, because I've never heard this clearly explained. Like I said, these three have traditionally been considered pollutants, not this one. Now this one is considered a pollutant, and it's being blamed as one of the causes of climate change. Another one is methane, and on and on. And I'm not going to debate whether carbon dioxide is causing climate change. It's not what I want to address. So for years, this was considered the ultimate goal of a perfect running vehicle. Now it is the enemy. And when you're starting to hear all of this discussion about eliminating the internal combustion engine by 2030 and gas stoves and all of that other stuff, coal-powered plants and natural gas power plants, the reason is because of this. And I never hear this discussed anywhere. Carbon dioxide, I'm gonna exhale. I'm gonna take a breath, and I'm going to exhale into the probe here. So you can see when I inhale, and then when my body absorbs some of the oxygen, and I exhale carbon dioxide. So I am a carbon generating climate change. I'm going to do this again. I'm going to take a breath, and I'm going to exhale into the probe here. So when I exhale, this is what I'm exhaling here. And you can see why I talked about the gas triangle, these exchange. I better not be exhaling any carbon monoxide. What you're looking at here is I'm sampling a perfect running clean car. So this is pretty much ideal emissions. We have low hydrocarbons, so the vehicle's consuming all of the gas that's going into the engine. Low carbon monoxide, so we have a good fuel mixture. Low oxygen, we have a good fuel mixture. It's burning, there's the perfect mixture to burn up all the available hydrocarbons. So there's a good balance between oxygen and hydrocarbons. But what we have is we have 15.3% CO2. Now this is percent. And what I'm gonna say, I always get challenged on, but look it up. Every gallon of gas you burn, you emit 20 pounds of carbon dioxide into the atmosphere. Diesel, 23 pounds. And I always get challenged, how is that possible when a gallon of gasoline weighs 6 pounds? Well, to burn that 6 pounds of gasoline, you're dumping in 14.7 pounds of air for every pound of gasoline, of which 21% of is oxygen. So for every pound of gasoline you burn, you're dumping 14.7 pounds of air, of which 21% is oxygen. Now, you end up with, for every gallon of gas burned, you end up with 20 pounds of carbon dioxide. This is percent. This is not volume or weight. This is percent. So this is the new boogeyman. This is the reason why you're seeing the push to get rid of internal combustion cars and burning fossil fuels. All right, I hope I explained that. These were the classic pollutants. And people all the time say, well, my car runs perfectly clean. Why is it a problem? It's a clean burning new car. Because the end result is being now considered a pollutant. It never was before, but it's now the #1 enemy. So that's why you're seeing the push you are seeing. I hope that makes sense, because I never hear that explained. So how do we reduce production of CO2? We reduce consumption of hydrocarbons, and we do that with better gas mileage vehicles, raising energy prices to force reduction in consumption, on and on. You get it. So hopefully after seeing that intro, this will make more sense. I wanted to take a second and address some of the most common comments that came up in the last Ford ECU repair video. The most common was the closed loop operation, that the engine needs to be above a certain temperature to go in closed loop. Although that might partially be true, these vehicles have California emissions. And one of the main things with California emissions was carbon monoxide reduction when the engine was cold. So these vehicles, basically starting in about 1988, went to a 4-wire heated O2 sensor. And these things go into closed loop as soon as the voltage on the O2 sensor comes up above about 0.5 volt. They'll start to feed back. I'll show you the 4-wire O2 sensor. That was sort of the most common. The other thing was a lot about the learned memory. And these are not like modern vehicles with complex fuel trims and mapping and all that. They're very basic. It's a very basic speed density system. It uses a map sensor. These do not use a mass airflow. And although there might be some keep alive memory, it's very limited compared to what we deal with now. This is like, what, Windows 3.1? the vehicle did get a radiator, and it is getting a new sending unit for the thermostat, which was, or not the thermostat, the temperature gauge, which was totally rotten. It's down in there. So here's the O2 sensor, and you can see it is a 4-wire heated O2 sensor. This also is a heavy-duty vehicle. See the size of the cat, monster cat. Pretty much all of my videos, whether they're TV, radio, or I'm doing some of these ECU videos now because some people seem to enjoy them. I mean, they're kind of all the same thing, but in my videos, I take you through the process of discovery, my process of discovery, because I'm learning and discovering things as I go along. So if you don't complete the video, if you just watch the first couple minutes. Another common comment on the previous video was how high the NOx was, the oxides of nitrogen. These are heavy-duty vehicles in California. The limits are much less stringent on vehicles over 8,600 pounds GVWR, which this is and the previous van was. So the standards relax like, I don't know, 200% on heavy-duty vehicles. So this being a heavy-duty vehicle over 8,600 pounds will probably have a NOx limit of like 2,200, which if this was, say, 6,000 pounds, it would have a NOx limit of like 500 parts per million or 550. That comes up later in the video. There was also some mention about live data. There's no live data out of these. Ford started some very limited live data in some of the 94, I think, is when they started it. But even then, it's just very limited compared to what we know today as live data. How about another possible ECU repair video? This is early 90s Ford F250. Seems like all the ECUs on these are just dying now. The capacitors leak, and this one has a lovely home latex paint job. No bother with this rust nonsense. We don't worry about that. Now the symptom here is sometimes it takes an hour to get this truck to start. And that can be a lot of stuff. That can be the ignition module there, it could be the coil, it could be the distributor cap, the rotor, that could be the fuel pump. But since we know that the ECUs are a problem with these things, and it's right here in this particular truck, it's not that hard to get out. It's probably best we just pull it and inspect it before we go out. Did you grab the key? See if it'll start today. We're gonna see if it'll start here. Maybe we can identify whether it's spark or fuel or both, or well, today it's fine, but we're gonna pop that ECU and inspect it. Here it is. This one looks like it has a little moisture damage to it. Let's get it open and see what the capacitors look like. Well, this one is certainly no exception. You can see the ECU sits up like this in the truck, and you can see the spooge is leaked out of this and run down. And also looking at these look really bad too. In fact, they look really bad. And in fact, the leads are totally corroded off. Look at this one. Same thing. The positive lead is just totally corroded off. I hope this is repairable. I hope that electrolyte hasn't worked its way into the middle of this multi-layer board and eaten up the traces. The previous one, the trace was broken right at this diode right here. Pop. Yeah, these are this one's really bad. And the symptom or complaint on this car, this truck, was occasionally it wouldn't start. Look at the date code, 9106, Nichicon. This one, clean up in aisle 5. All the negatives are on this side. 10 at 63, 47 at 16, 47 at 16. Once you get them off, you can really see the damage. And usually the vehicle will not exhibit problems until the traces are eaten. You could take these capacitors out and throw them away and you wouldn't notice any difference, I don't think. At least it wouldn't cause it not to run. Well, this one is, yeah, an extra mess. Extra mess. All right, there it is, all recap. Now, I will say this. If below that pin right there, there are any traces in the middle of the board that connect, this thing is dead. Because the eyelet just completely was rotted away. Yeah, this one was in bad shape. Really filled the room with the scent of fish when I was cleaning the solder off. So we'll see. This one might end up having to replace this one. But we gave it a good try, I think. Yeah, give me a second. We're good. We got it back in. What we're going to do is see if it starts, and we'll pop it on the dyno. We'll look at emissions for closed loop and EGR operation. We'll check for timing advance. If it even starts. Go ahead. Since we have the equipment and the option to do the correct testing, let's see, we'll do 10 horsepower. That seems about right. And yeah, we'll take a look at the gases, timing advance, shifting, all of that. So carbon monoxide is your rich lean indicator. On this, it should be around 0 because it's got big catalytic converters and an air pump. Your oxygen should be probably around 3% at light cruise. So these are really what we're looking for. NOx, if the EGR is not working, that could be an ECU problem. The NOx might be high. This should probably be around, I don't know, 200 to 400, say ideally. CO2, we don't really care about that. We're really interested in these two and sort of that one. If this is too low, could be lack of timing advance. All right, go ahead, start it. Now it'll take a minute to drop into closed loop. Now we might have to restart it again. Okay, drive it at, I don't know, 15, 25. It's cold. We're still not in closed loop yet. Okay, there I think we just went into closed loop. Okay, let it idle. I think that catalytic converter is real tired. Okay, stop. It's in closed loop. Okay, go ahead, accelerate. Actually, hold on. All right, engine RPM, miles per hour, CO. I'm gonna take the load down to about 4 horsepower. We're gonna look at transmission shifts now. So we're looking at RPM and mile per hour. Okay, go ahead. Take it up to about 55, 60. The hell, is this thing a 3-speed? Really? No overdrive? Alright, I guess this thing is well, that's not working. Let's see, is this... It does have a check engine light. I guess this is just a 3-speed. No overdrive in this thing. Wow. What a pig. I didn't even know they had that in 90s cars. Doesn't have the switch. Two, three. Well, the EGR finally did start opening because this is hot as hell now. So, and it'll set it. These things will set a check engine light in a minute if the EGR is not working. They're really known for these vacuum lines breaking, these hard vacuum lines. So I think we're a success here with this ECU recap. We'll have to try it for a couple days and see if the no start complaint comes back, but this will simulate an actual California emissions test for this specific vehicle. You'll see up at the top when I start driving it what's passing and what's failing. Wow, the NOx limit is a lot higher than I thought. So it's passing. Good, it's good. It's good, it'll pass, runs good, passes California emissions in closed loop. Yeah, I would say we conquered that ECU. That was a bad one too. That thing was really eaten up. Well, the ECU might be good, but the radiator's junk. Focus in on those bubbles there. Needs a radiator. And the hoses are all soft. So if you put a new radiator in it, then it's going to start to build up pressure and blow the hoses apart and probably blow the gasket out of the timing cover and the heater core and start leaking from everywhere. It's water pump. So this thing's baked. I decided I would take this guy on a little bit of an extended road test, you know, just because it's such a beauty, and been doing good. And I looked at it a little bit closer. It is a heavy duty model. It's GVWR is like 8800, and that explains the 3-speed automatic versus the overdrive. And that also explains why the NOx limits, the oxides of nitrogen limits, were so much higher than I thought, because the state allows a much higher NOx on heavy-duty vehicles, because the EGR really doesn't start to open on these until you're under a really heavy load. So it seems to be running pretty damn good. The dead engine temperature gauge and oil pressure gauge would drive me nuts, especially with all the soft rotten hoses and the leak in the radiator and everything else. Man, this is playing Russian roulette. Hope that doesn't get my video banned today.